Okay, now I'm back. Figured out what I forgot. So we we got to the point where we saw that at the time of ruin, the accumulated capital growth, well, must be smaller than or equal to minus u, because that is by definition what we mean by ruin. And then I wrote something that confused myself a little bit, because what we then want to do is we would like to talk about, well, how does e to the alpha st then look? But that is fortunately quite manageable, because, well, recall that we assume that we consider alphas that are non-positive. That was part of the exercise description. Show for all alphas smaller than equal to 0. So we have assumed that alpha is smaller than equal to 0, and therefore now when we multiply st by alpha, what's happening? When we multiply st by alpha, let's just do this here. When we multiply st by alpha, we have to turn the inequality around. And that then implies that e to the alpha st is greater than equal to e to the minus alpha u. And therefore, this goes on to manifest in the mean value. So this mean value is greater than the mean value of e to the minus alpha u minus delta u multiplied by the cumulant generating function multiplied by the indicator function of t being smaller than equal to delta u. Now this is incredibly nice, because this entire term here is now deterministic. And we figured all this out just by considering, well, how do these different variables behave when we know that the time of ruin is bounded. So this is something that you can do when you, well, first of all, when you assume that the time of ruin is bounded, and secondly, when you assume that the time of ruin is bounded specifically by this boundary. So we can take the deterministic part outside of the expectation, and what you have left inside of the expectation is just an indicator function. So that is the probability that t is smaller than equal to delta u. And if you recall, all the way up in the beginning, we had a 1. So what we have now is that 1 is strictly greater than this thing here. And the thing that we wanted to find a bound for was choose a nice color. So in conclusion, well, the thing we wanted to find a bound for was the ruin probability on a finite time horizon. And that probability we then expressed using the probability that the time of ruin does not exceed this time horizon. And this probability is something that we have just derived a bound for, because you have the probability here, and if you just multiply the exponential expression over on the other side, then you have e to the minus u, and what you then have on the inside is minus alpha minus delta multiplied by the cumulant generating function. And I think if you look at the exercise description, then what you will find is this expression here is exactly that function g delta of alpha that we were asked to find. Now we will end this video here, and then the next video I'm gonna do the second part of B, which is fortunately a lot easier, and then we're just gonna end everything by doing a quick solution of C.